Hello and welcome. Ray Chrisman here from R.L. Chrisman Metal Works. Well, I finally got back to working on this spindle spider. Sorry it's been a little while. But anyway, I jumped ahead a little bit and I've actually drilled some of the holes in here for the spider screws. I've actually got two of the holes for the spider screws, and I've got one hole for a set screw to attach this to the outboard end of my spindle. But anyway, I thought I'd continue on here and drill and tap some of these holes, the rest of these holes, and then I'll show you what I've got there. I did order in the spindle screws, the spindle spider screws. What I ordered was 5/16 18 by 3/4 inch long brass tip set screws. I probably should have gone with 5/16 24, so there'd be a little finer thread, a little bit more adjustable maybe, or at least finer adjustment. But I didn't have a tap for 5/16 24. I had a tap for 5/16 18, so I just went with those. I figured for my purposes they would work just fine. Here's what those screws look like. I'll get into that a little bit more later on and explain why I went with 3/4 inch instead of something a little bit longer. The 3/4 inch won't reach all the way to the center to where all four of them would touch. But I figure I'm going to be probably not using anything in that spider that's smaller than 1/2 inch. So I figured I didn't need anything longer, and I didn't want them, when they're installed, I didn't want them sticking way out here when they're installed and in use. So I went with the shorter ones. You could go with longer ones if you wanted to be able to have all four of them touch in the center, but I didn't see a need for that right now. So anyway, I'm going to go on here and I'm going to drill some more holes. What I've done is I've got that adapter piece, that spindle spider adapter piece, mounted in my vise on my mill drill. And when I started drilling the other two holes that are already done are in the sides here. What I did was I used a 1/4 inch end mill and went back and forth across to find the center. And I used that as my centering device to find the exact top center on this round surface. I wasn't as happy with that as I would have liked. It worked, but it's not quite as accurate. I think if I made another one of these, I would actually put it on my rotary table and do it that way. But in any case, I did put two flats on the sides here and use those to center with for the first two holes. And I'm also using those flats. The first one, I put it back against the fixed jaw. Actually, I put it straight down to drill the center hole, so that way I knew I would be straight across from it. In this case, I've got the flat against the fixed jaw. There's another flat against this jaw. And I'm just using that to get them every 90 degrees around that circle. And then also what I did was, every time I take this out and reinstall it in the vise, I'm using a parallel across the end of the vise and adjusting this piece up to where it's touching the parallel, so everything should be at the same distance in. And I've just come in 1/2 inch from the very edge to my center where I'm putting these spider screws in at. Anyway, I'm going to continue on here. I'm using a small center drill to start my hole, and then going up with a bigger drill bit, the tap size drill bit. So anyway, let's get on with it here. about empty. Let me get a different bottle of cutting fluid here. Okay, let me take that center drill out. And then for my cap drill size for the 5/16, according to my chart, I need a letter F drill bit, which is what I have right here. That's what I've been using. Let's add a little bit more cutting fluid here. Drill that on through. And let me get my cap back out here. Okay, I found the tap. It was actually in my tap handle. I want to make a spring-loaded center, or a spring-loaded tapping device, but I haven't gotten around to that yet. So let me show you how I do this, at least for now, so that I can get this tap started so that it's true with that hole. I just go ahead and put it in the drill chuck. Get some tapping fluid on here. Some on the tap. Without readjusting anything, I can just put that in the chuck and bring it down and turn the chuck by hand and get that tap started. I know that the tap is started straight that way, and it is started, even though not very far. It is started and started straight. So I can take it out of the chuck, put my tap wrench on here, and I can continue tapping. And since it's already started and it had cut the threads a little bit, it'll stay straight. And then I know that that tap is going in true with that drilled hole. And as always, you want to make a turn or so, back up the tap to break the chips. Take another turn, turn and a half, something like that. Back up the tap, break the chips, and tap it on through. And you want to go in far enough so that you're past the end of that taper on the tap, because I am just using a taper tap. I don't have any plug taps or bottoming taps or anything like that. All I have is taper taps. I have a very small selection of taps right now. I need to get some more. But anyway, that's how I have been doing this. Let me get one of these screws and show you that it does fit in there. These are the brass tipped set screws that I'm going to use in this spider. And the style I ordered was for a hex key or an Allen key. That was just my preference. I ordered these screws from McMaster Car. They came in a package of 10. I only needed 4, but they gives me some spares. And they weren't very expensive. I think they were only, I want to say $7 for that package of 10. They weren't very much. I don't remember the exact amount right now. But anyway, so that's what I'm doing. I've got one more of these holes to drill and tap. So let's get on with that. And I'm still trying to decide for the set screw. Now let me pull this out of the vise and I'll show you what I've got. Wipe this off a little bit. You can see here I milled a flat here. I'm not sure how well that's showing up on the camera. I milled a flat here to get the first hole. And then I put that in the vise with that flat down to orient it. Milled another flat to center to find the second hole. I moved back and tapped a smaller hole here. I believe this one is a 1/4 20 if I remember right, because I had some 1/4 20 set screws. And that's what I'm going to use to set it onto the spindle. Anyway, I'm still debating on if I want to put more than one set screw on that or not. I think one would actually hold it, but I may end up with 2. I'm not sure yet. But I have 3 of these spider screw holes drilled and tapped. I need to tap one more here. So let's get this set up and do that one. Wipe all the chips out of the vise here so everything is true. Wipe this off so everything is true and clean. Okay, now I'm just going to use these flats to orient this in my vise so that that next hole is 90 degrees. And I can feel when all the flats are touching. I need to take a file to this last hole. It's got a burr on it that's sticking up, so it doesn't want to sit down in the vise properly. Let me just take a file and take that burr off of there. This off again here. Okay. Now, like I said, I've got those 2 flats, and I can tell when that flat is flush with the fixed jaw on the vise, which it is right there. I'm going to use something as a parallel, just a flat surface, go across the end of my vise and make sure that this piece is touching that. That way it's oriented at the same distance in on every one of these holes. Okay. Now we'll go back to the center drill. I like to start my holes with a center drill. especially on a round surface like this, because it's stiffer and it won't flex, and try to track off center on that rounded surface. Cutting oil on there, so we'll be set when we start drilling. Drill bit out. Get the tap out of the tap handle. Put it up here in the drill chuck. Just to start this again. Like I said, I want to make one of those spring-loaded centers to hold that tap. It would make the process a little easier, but this does work. Get the cap started. I'm just putting a little bit of pressure on the spindle there. Down pressure to start the tap. Loosen up the chuck. Put the tap handle back in here. A little bit more tapping fluid on here. Break the chips. Another turn. Break the chips. And I'm down past the taper part of that tap, so we can pull that back out. Just a little bit here. I don't have a deburring tool yet to just go around that hole and deburr it, so the file works fine. Deburr the inside of those holes also, just a little bit. So let me find my round file. What did I do with it here? just saw it a minute ago. Of course, now that I want it, I can't find it. Well, this isn't the one I had been using, but it'll work. This is actually just a chainsaw sharpening file, but it's round, so it works real well to get inside on this round surface and just knock the burrs off the inside of that hole where I tapped it a little bit. Doesn't take much. Okay. I'm going to see if I can move the camera here a little bit. Hopefully I won't make you too seasick. I'm going to try to zoom in on the end of the spindle over there on the lathe. Okay, let's continue on here. As you can see, I've installed those spindle spider screws here, and I can use an Allen key on those to adjust them. How far they're in when they're flush with the outer edge here, and I haven't really measured it, but I think that's about a half an inch, approximately a half an inch in here. Yeah, it's actually 3/8 of an inch with those screws flush. The reason I wanted the shorter screws is because, like I said, I think that most of the time I'll be using this, if I do use it at all, I'm going to have something in here that's a half an inch in diameter or slightly larger than that. So I didn't really need these screws to touch. And I didn't want them hanging out here a long ways to get caught on something while this is rotating. That's why I went with the 3/4 inch brass tip set screws instead of going with 1 inch or something even longer than that. I think these will work just fine for me. But anyway, there you should be able to see those screws in there. And then I also have a set screw here. And this will just slide right on the end of my spindle there. Back that screw on a little. I think I've still got a burr on that hole for that set screw. Let me see if I can get rid of that. And I'm just going to use a little bit of emery paper here. My file won't reach in there to get to that. Okay, let's try this again here. There, that slides on there a lot better. You can see that set screw be over the spindle. The spider screws are out here. Now what I need to do is I want to drill a detent in that spindle for that set screw so that it'll actually lock in there real tight. So what I'm going to do to find out where that needs to be is I'm going to put a little bit of die-chem on that spindle. Tell I don't have a lot of room there between the mill and the lathe. I'm actually quite limited on shop space here. One of these days I'll show you why. Show you how small of an area I'm really working in. But anyway, let's put a little bit of die-chem on the end of this spindle where I want to drill that set screw detent hole. Get that die-chem to dry a little bit. It's actually a little on the cool side out here in my shop today, so it's not drying very quickly. I don't have heat in my shop, which I need to do something about. But blow on that die-chem a little bit and it'll dry. Okay, let's put this on here. I'm going to tighten that set screw down and see if it'll put a mark on that shaft. So I'll be able to tell where I need to drill that. And it did mark it, actually marked it quite well. So that was a good trick, that worked. Now, I need to find a center punch and just lightly tap that. I don't want to tap it too hard because I don't want to be pounding against the bearings on that spindle, but I do want a mark there that I can start a drill on. Okay, I did find my center punch. Now let's see if we can put a mark on here. Okay, I think I can work with that. I'm going to use that little center drill again to start this hole. Okay, here we go. Turn that compressor off so it's not quite so noisy, and turn the camera off here a minute. I'll give you a closer view of that set screw hole that I just drilled there. Okay, I'm back here. You can see that hole that I drilled there for the set screw, and I used that small center drill because of the taper that's on it. The set screws that I have, see if I can get one in focus here. Set screws that I have a taper on them, and with that small center drill, the taper, let me see if I can get this around here to where, you know, it doesn't show up very well, but the taper on that set screw fits quite nicely in the taper that I drilled there from that, with using that center drill. So I think that's going to be a good positive locking action for me there. Let me turn the camera off here again for a second, and I'll install this on here, show you what it looks like when it's all installed. Okay, here we go. I got that installed on there. Got the set screws tightened up. See if we can get a shot right down the center of the spindle here. You can see there through to the tailstock. Move the camera around, see if we can get a shot from the other end. Okay, here we are. There's a shot looking down through the spindle from the chuck down towards that outboard spindle spider. As you can see, should work quite well down there. I'm going to move around to the other side again. I went ahead and installed the guard that goes over that gear train down here. And I'll show you why I wanted to keep my spindle spider set screws so short. You can see it's recessed back inside that guard there a little bit. And there isn't an awful lot of clearance. I mean, there is some. There's a good probably 3/4 of an inch or so, but I didn't want those screws sticking out very far on that spindle spider when I have a piece of stock installed in there. So that's why I went ahead and opted to use the 3/4 inch long screws instead of something an inch or better, because like I said, if I have something in there, if I had a rifle barrel in there, you know, to thread or chamber, if I was going to do that, the end of that rifle barrel is going to be, you know, a good 1/2 inch, a little bit better, 9/16, somewhere in that area. And I don't want those screws sticking out the outside edge of that spider adapter far enough that they're going to hit on that guard. So that's why I opted to use those shorter screws that won't actually go all the way in and touch, because I feel they don't need to. If I'm using it on a piece of stock, they're never going to touch anyway. They're going to be touching the stock. And like I said, I would think anything I'm going to use in there is going to be 1/2 inch or bigger diameter. So anyway, that's the completion of this project, the outboard spindle spider on my YCL-1340 Metal Lathe. I'm Ray Chrisman. Thanks for joining me here today. Until next time, happy machining.